So today we're taking a quiz, but if I just point blank gave it to you, you wouldn't do that well. Some of them would be fine, but some of them, especially later in the quiz, are going to be significantly harder than what I think you could handle. And so we're going to start with a nice, easy little warm-up, and then we'll get into the harder stuff. Okay, so here's a nice, easy warm-up. If this is a quadratic, y equals x squared plus 6x plus 1, what's its vertex? You should be able to find the vertex two different ways. With this one short little formula, x equals something. And then the other way is with complete the square. I'd like you to do both. I'll pause for a second while you solve this for the vertex, like what the heck is the vertex, using the x equals formula and complete the square. And then they have to both get harder. Like I have to show you how to find it when it's not such a nice, easy quadratic. So here we go. X equals negative b over 2a. You need to have that one memorized. And then that, in this case, is negative 6 over 2 times a, which is 1. So negative 6 over 2, which is negative 3. Once you know that, you have half the vertex. And the vertex must be negative 3 comma something. How do you find the other half, Jada?
You plug the negative 3 in for x.
All right. Negative 3 squared plus 6 times negative 3 plus 1. And then that's 9 minus 18. And you're going to notice this weird thing where these are always half of each other. Like one could be negative, one could be... They're always going to be half each other and usually opposite of each other too. So anyway, that turns into negative 9 plus 1. What is negative 9 plus 1? Negative 9 plus 1? Negative 8. Negative 3 comma negative 8. Raise your hand if you had that one right. Okay, cool. Now, I know already that it's negative 3 comma negative 8. I'm only doing this other way because we can force you on the test to show us that we know how to complete the square. And we have ways of making you have to do that. You might think, well, I could just always do this other way. Well, if nothing else, it'll be right on the test. Show that you know how to complete the square as you do this problem. Now, you could find negative b over 2a and know that that's the vertex, but you still have to be able to show us that you can do this. So 6x plus, notice me moving the one way over there, and then you go half of this and then square it. Half of 6 is 3, 3 squared is 9, so I put a plus 9 and then a minus 9. And then this is x plus 3 quantity squared. And then this is negative 8. And look at that. This and this match up. And yay, life is good. Okay. But I warned you, they have to get harder than that. So complete the square except much harder. What if it doesn't come out nice and it's got a fraction in it? That's not that much harder, Mr. Server. I can handle fractions. Okay, awesome. Let's make them negative fractions. Negative 5x plus 1. Now, complete the square to find this. I know you could use negative b over 2a, but trust me, right now, I'm trying to teach you complicated completed the square because I know what you're going to have to do someday. So use complete the square. Now, let me show you the fast way because there's the slow way and the fast way. I think most of you knew that you're going to have to move the plus 1 over, and then you're like half of 5 is 2.5. Don't do it that way. Let me show you this way. It's faster. Half of negative 5 is negative 5 over 2. That's half of something, right? And you might be like, why would I do it that way? This other way is faster. I'll show you, and you'll like it. Because now I have to do the opposite of that out here, and now I can just go ahead and square them both, and I know that means that it's 25 fourths. And some of you are thinking I was going to do that in the first place. Here's why you don't want to. 25 fourths out here needs to be negative because, you know, this one's going to turn out positive because you're going to square it. So this one needs to be negative. But why do this weird clunky fraction thing, Mr. Server? Because I now can just put negative 5 halves right here squared. It's factored and I'm done. If you had made that 25 fourths, you'd then have to take the square root of it again to figure out what to put here. Okay? And then this part, yeah, I'm going to be honest, I wish I had made this 4 over 4. I now have a common denominator, and then I could have got the answer really easy, negative 21 fourths. Could you leave it like that? Sure. There's nothing wrong with that. And there, I'm done, and it's all fractions. What's the vertex? 5 halves, comma, negative 21 fourths. Martin. Well, we factored. So this is the factored form of this. And the reason that this is smart to do right here as a fraction is because then it can just be copied down right here. If you had squared it out and made it 25 fourths, then you'd have to take the square root of it to figure out what to put here. Yes?
Can we do one where A isn't?
Yep, I'm about to do that next. Yep. I'll make sure you get the fraction kind first, though. All right, so I'm going to do one more with a fraction because I would bet money that not many people would have had that one right. So let's see if you can do it now with a little bit of coaching behind you. So y equals x squared minus 7x minus 4. Go ahead and complete the square on that one. And the answers are going to have weird fractions in them. I'll pause for a second while you complete the square, which finds you the vertex form. Let's see how you do. So hopefully you could start by subtracting negative 7 over 2. And then it's squared though, because that's half n squared. Then I'm going to put a parenthesis around this just to show you that's the part that's going to get factored. Then I need to do the opposite of that, which is plus 7 over 2 squared. But I'm going to actually square it out and say 49 fourths. You don't have to, but I think that's the easiest way. Then I have the minus 4 here from the end. It's just there. And wait, one more thing. This one is the positive one. It will be because we square it. So then this one should be a negative one right here. It should be negative 49 fourths. Okay, y equals x minus 7 halves, quantity squared. Now that's because we used the half and square method, and that just goes right there. It's pretty easy to make that negative 7 over 2. And then this part's not very fun. I'm going to put it over 1. I'm going to times it by 4, times it by 4. And that's going to make it negative 16 and negative 49 makes 50, 64 is 65. Thank you. Negative 65 fourths. Whew. Raise your hand if you had that one right. Good. Okay. Now it gets harder. I was asked a bit ago, and I did this in the other class 2 course, to do it when there's a number in front like this. I'm putting the minus 1 way over there just because we all know this is going to be complete the square. So what do? You still do the half and square thing, but wait, you need to do something first. Notice that this part here has a 4 in common. I'm taking it out. And I know some people are thinking, well, that's impossible because there's not a 4 in this one. No, it is possible. You can do that. I just factored this stuff in the red parentheses, and I didn't factor this minus 1. And I can do that. If I multiply it all back out, it'll equal the original one. So I can do that. I factored the 4 out. And now I'm going to do my half and square thing. Half of negative 4 is negative 2 squared is 4. Oh, sweet. There's no fractions in this one. There's a plus 4. Here's a minus 4. But wait, something is wrong. And I usually can get some kid in class to figure out what is not working about the process as is. Yes?
The 4 on the outside of the parentheses has to be multiplied by the 4. It's multiplied with parentheses.
This is going to increase the value of that to 16. So this one has to also be multiplied by 4. Because this 16, after you multiply by 4, has to cancel this negative 16. And this is the key right here. A ton of you are going to forget this on the test. That has to be multiplied by 4. Why? because again, this and this would make positive 16. So now this and this will make negative 16. Okay, so that 4 right there that got factored out in front, that's one of the most forgotten things, is that has to go right there. So then it's 4, parentheses, x minus 2 quantity squared. Did you notice there was a minus in there? And then negative 16 minus 1 makes negative 17. Boom, I have factored it, and I now know the vertex is 2 comma negative 17. Yes?
Okay, what if you can't factor it out? What if it was...
If you couldn't factor it out, then you couldn't do that problem. But you always can. If we were to be really brutal, you'd be like, well, you can't factor the 6 off. Yeah, you can. You can factor the 6 out, and you'd have x squared plus this. Both this gets divided by 6, and that gets divided by 6. You get how it would be 1/2 x. Not asking you to do this whole one. I was asked what would happen if it was hard to factor it. Well, then it's just hard to factor it, but it could still get a 6 factored out so that this can have nothing in front of it. And then this got to be weirder. And what happens if you want to take half of a half? It's a 4th. Very good. You could do that. Okay, good enough on that. That's just to show you it could be done. All right, what else do we have to make harder today? Well, I've talked about discriminants before, but I bet you barely even remember discriminants. B squared minus 4ac. Can you just remind me the easy part about discriminants? Like, what if I wanted to have a discriminant that was greater than 0? What would that mean? The equation would have, write it down, don't say it to me. What would that mean? What would this mean? And what would this mean? There's 3 cases for the discriminant. Remember, this is in the quadratic formula, and it's under a root. So when you have that thing, that gray thing, is under a root, it can't be negative. Otherwise, it can't have square roots of negative, so. All right, I'm going to pause for a minute and see if you remember the 3 cases for the discriminant. Owen, do you know any of the 3?
Sorry, I'm still
Okay. Nick, do you know any of the 3? I'm trying to show people what the answers kind of look like.
D equal to 0, like, there's like
One solution, very good. And because it's 0, the whole discriminant disappears, and what you're left with is something special. Do you remember what that is?
No.
Okay, let me show you. X equals negative b plus or minus a square root of, I'm going to change colors, b squared minus 4ac all over 2a. Do you get if the red part was 0? Then all you'd really have left is that. If the red part was 0,
Solution.
it's just the vertex. You'd have one solution, and it's the vertex. Jada, how many solutions do you get if d is greater than 0?
2.
2 solutions. How many do you get, Jada, if d is less than 0?
None.
No solutions. Because if it's less than 0, you have a square root of something less than 0, and that doesn't exist. Okay, so those are the 3 cases, and now just remembering that's like, so what? Well, let me show you. Imagine I give you an equation, and I give you mx squared plus mx plus 3. And that's a quadratic, isn't it? Yeah, it is. Depends on what m is. But what if I wanted this quadratic to have 2 solutions? Well, then didn't I just say that I wanted its b squared minus 4ac to have 2 solutions? It should be what?
Greater than 0.
So figure it out. What do we have to know about m? What would m have to be in order for that to work? I'll pause while you try that. Okay, so b squared minus 4ac in this case is m, because that's what b is, squared minus 4 times A, which is also M, times C, which is 3, is greater than 0. Now I'm going to clean it up a little bit. M squared minus 12M is greater than 0. And now M can be factored out. That's the step a lot of people miss. No big surprise to me because people just don't see factoring. And then I got two answers. If you haven't gotten this far, please get this far. And I got 0 and I got 12. And then those two spots don't work because this doesn't say or equal. If you wanted to check, you could stick 12 in and it makes the whole thing 0, and 0 isn't greater than 0. So that's why those are empty circles. And then if I want to test something easy in the middle, like I could test 1. 1's between 0 and 12. And I go put a 1 here. And is 1 times negative 11 greater than 0? No, it's not. So that didn't work. So that means I'm going to shade here and here. And so that means my answers for M are M has to be less than 0 or M has to be greater than 12. Get how that finished?
Can you show the full equation again? Like the full. Thank you.
We started with variables in here. Otherwise, you would have been able to tell me how many solutions it had. If I just give you a normal equation, like 2x squared plus 8x plus 4, you'd be able to use b squared minus 4ac to tell me how many equations it has. But because I put variables here, I can tell you that it has 2 solutions, and you have to know this. Then b squared minus 4ac must be bigger than 0. All right, you'll get a chance to practice that tonight on the little quiz that's coming up here momentarily. Yes?
If you solved it a different way, would you get a different answer?
Nope. You would have, well, I should say it this way. If you did it right a different way, you could get the same answer. But I'm not going to show you the other way because we're going to say you have to use complete the square. So therefore, I only want to show this way. I could show another problem where you have to complete the square, but frankly, we're going to run up with against time. So I think it's going to be one more thing that I want to make sure to cover here. Just a couple announcements. We don't have the test this week. You guys all have Friday off, and I don't. I'm going to be working hard. But then Monday we have our review, and Tuesday of next week is when the test is. Okay? You can still take the top 20 either Wednesday morning during MAST or Thursday. You just need to ask me if you want to come in for Wednesday MAST, and I'll sign you up. Then later in this hour, I'm going to have kids come up and take a look in the closet here because I have a special mirror, and I'm just going to talk about face symmetry for a second. If you look in the mirror, in a regular mirror, do you know that what you've been seeing in the mirror is not exactly how you look? It's flipped. So like, for instance, a kid that shirt says Florida on it, it wouldn't say Florida when you look in the mirror because it's backwards, right? What does that mean about your face? It's flipped. It's backwards from how it normally looks. So when you look in the mirror, you're kind of convinced that's what everybody else sees, and it's not. It's not what everybody else sees, unless they all see Florida backwards when they look at your shirt, which they don't. So your face has been flipped this whole time. And in fact, and people don't like how their face really looks because you've been so used to looking in a normal mirror that you don't know how your face normally looks. So when you look at how your face actually looks to people in this mirror, this is a true mirror. It's got a reversing technology of having 2 mirrors at exact 90-degree angles to each other, and it flips your face back so you can see how other people look at you when they look at you face to face. When I look at you right now, that looks different than what you think it looks like because you've been looking in a normal mirror your whole life. People don't like it, and I can prove it because if people liked how you actually looked, then selfies, when you take a selfie, I don't know if you've noticed this, but Florida's still backwards in the selfie. So they take the selfie, and Apple on purpose flips it because you wouldn't like it if you saw what you really looked like. Because that's not what you're used to. So they flip the selfie over so you see it backwards, just like as if you looked in the mirror. Okay, so I think you'll find it interesting to see what you really look like. And that has to do with y-axis symmetry. Okay, which means in the end, you are an even function.
I'm actually more
Deep.
interested in the minions back there. What are those?
Don't touch the minions. Okay, so every good superhero needs minions. No, super villain. Sorry. All right, so what if your quadratic had this in it? X squared is greater than or equal to negative 4x plus 12. Oh, then you can't do it, Mr. Server, because it looks different. Oh, actually, what do you just do first? Not factor it yet.
Make it equal 0.
Make it equal 0. Then factoring is always a good idea. If you can factor it, you should. All right. And what if it's a quadratic, though? The quadratics, or no, I mean absolute value. Well, absolute values are different because absolute values, when you solve them, you get your two things. You know, like x minus 3 is greater than 0, and x minus 3 is less than, notice me switching the sign, negative 0? What the heck? Well, negative 0 is just 0. But this one's one of those weird ones. I would recommend that you had graphed this quick and said, okay, y is this, which is a shifted to the right v shape, and this is 0. When is it greater than 0? Almost all the time. Because at this one moment, it's equal to 0, and that's not greater than 0. So weirdly, this will only have one answer. All right, so I just want making you think through some complicated things, and now you have the quiz on this. It is a virtual. I do have a few kids with IEPs and 504s who might benefit from a paper version of this, and even if you aren't on an IEP or a 504 and you really would prefer a paper version, I would like for you to all get it up on your iPad first, though, so you can see where it is, see that many of the problems won't be that hard. Oh, one last thought. They do have square roots in them, and if you had to add 2 root 2 plus 5 root 2, do you get that is not like going to require incredibly hard math? What is 2 root 2 plus 5 root 2? 7 root 2. Don't overthink those, okay? You're going to have to do some stuff with adding or subtracting of roots, and as long as this can be handled by just putting them together, for example. All right. Okay, and there's also some stuff about slope, and hopefully you remember what perpendicular means. Perpendicular ones have to do with, you take the slope of the original one and you do something to it. All right, so start that quiz, and if you're one of the people who really could benefit from a piece of paper version of that, raise your hand and I'll come around. And that's all I got for the video for today, leading up to the quiz, which is the main event for today. You will notice there is no key for it. I don't mind if people work together on this. In fact, I'm going to encourage it by having people that are near each other in class slide next to each other and help each other out. But there's no answer key posted until we are all done and we grade it in class. Okay, so do your best, and you may work with others, but your paper is what the grade you get, not, you're not like working with others and then we're going to turn hers in. Otherwise, we're just work with Jada. All right, that's all I got for you for today.